Hello everyone, so today I am going to continue the integrations exercise 7.2, the questions number 34 onwards. So the question number 34 we have given integrate under root of tan x divided by sin x cos x and into dx. Now how we can integrate it directly? Actually in this exercise we are applying the substitutions method. So in these questions what we can substitute to simplify it directly, here we cannot substitute anything. So first we will simplify it little bit. So first integrate, multiply and divide this denominator with the tan x, with the cos x. So here it will become, one second, here tan x will be as it is, integration of tan x, but this will become sin x. We are dividing the sin x with cos x, we are dividing the sin x with cos x and multiplying the cos x again with one more cos x. So it becomes cos square x into dx. Now further what we can do here, we can write integration of the tan x, and now you can see this will become denominator part. This is also tan x because sin x upon cos x is tan x, and this cos we can write as this secant square x and then dx. Now we can substitute here. What we can substitute here? We can assume this tan x. Let tan x is equal to t. Now differentiate both sides, so it will become secant square x into dx, and this is equal to dt. Means here now this secant square x into dx we can replace with the dt. So our I will become, now I is equal to, now it is equal to tan, and tan is equal to, we know that it is t, so it is under root of t divided by t, and here it is dt, right? So we can simplify this under root of t by t. Under root of t means power is 1 by 2 and minus power 1, so it will become minus 1 by 2, t power minus 1 by 2 into dt. So what is the integrations of this? Integrations will be, here minus 2 will come here, and this will become plus 1 we are doing, so it will become t to the power 1 by 2 plus c. We are applying the formula. Which formula here we are applying? Because we know that x to the integration of x to the power n is equal to x to the power n plus 1 divided by n plus 1. So if you apply this formula, we are getting this. Now we have to finally replace the t, so it will become minus 2, and power 1 by 2 means root, so root of t means tan x, so minus 2 tan x, and actually it will be plus only, not minus, because 1 by 2 we are getting, so it is plus 2 tan x plus c. So this is the answer of the question number 34. Now we will move to the next questions, that is question number 35. So the question number 35, here we have given I equal to 35, one second. So I equal to, here integrate 1 plus log x whole square, and this is divided by the x. How we can do that? Into dx. How we can do that? It is very simple. Directly we can assume the numerator terms, that is 1 plus log x. Let 1 plus log x is equal to t. So if you are taking this is equal to t, now integrate or differentiate actually both sides with respect to x, so it will become 1 by x into dx, and this is equal to dt. We can see here very clearly we have dx, and 1 by x term is present already in this question. So I will become, now I is equal to, we can say it is t square, and this is dt, and t square differentiations we can write very easily. It is t to the power 3 by 3 plus c. So now we can replace t with the values. So 1 plus log x whole square, sorry, it is whole cube, so whole cube and divided by 3 plus c. So this is the final answer of the question number 35. Now question number 36. What is question number 36? So we have given here 36, I is equal to x plus 1 and then x plus log x whole square, and if you divide it by x and multiply with dx. So how we can integrate it now? So first of all, we are going to substitute, very easy question, substitute what, this x and log x part, because we can see their differentiations is present already in the questions, given question. So t, now differentiation of x is 1 and log x differentiation is 1 by x. So and then here dx, and this is equal to dt. So now take the LCM. If we are taking the LCM, it will become x plus 1 divided by x into dx, and this is equal to dt. And this thing is already present in these questions. X plus 1 divided by x means now our I will become, I is equal to integration of t square into dt. Exactly same answer we are getting like previous questions. So t to the power 3, and here 3 plus c, but t value is this time different. Here it is x plus log x and whole cube divided by 3 plus c, 3 plus c. So this is the answer of the question number 36. Now we will move to the question number 37. So what is the question number 37? So 37, I is equal to, we will see here we have given x cube sine of tan inverse x to the power 4, and this is divided by 1 plus. By seeing the denominator, actually we should get the idea what substitutions here we need to apply. We can see in the denominator we have given 1 plus x to the power 8, and that will come from the differentiation of tan inverse x to the power 4. So we can assume, let tan inverse x to the power 4 is equal to t, right? So now we know the differentiation of the tan inverse x is 1 by 1 plus x square, but here power is 4, so it will become 1 by 1 plus x to the power 8, right? And by the chain rule, because actually basically we can write it as x to the power 4 whole square, and the differentiation of x to the power 4 is 4x cube, 4x cube into dx, and this is equal to dt, right? If you have any confusion here, actually it is nothing but x to the power 4 whole square. So we have taken here the differentiation of x to the power 4 by the chain rule. So this is the differentiations. Now we have x cube divided by 1 plus x to the power 8 in the given questions. So we will write here, and this is, we will take the constant term right side, it will become 1 by 4 into dt. Means now this I become what, I is equal to integral this tan inverse we have considered t, so t, and this is dt, but this constant 1 by 4 we will write outside of the integration. So what is the integration of this? It will become 1 by 4, and here it will become t square by 2 plus c. Now t square value, t is equal to, we know that tan inverse x to the power 4, so tan inverse x to the power 4 whole square divided by 8 plus c, 8 plus c. This is the answer of the question number 37. Now we will move to the next question, that is question number 38. So what is the question number 38? 38 is the objective questions actually. Here we have given I is equal to integrate 10x to the power 9 plus 10 to the power x and log base e and 10 into dx, but this is also divided by, this is divided by the x to the power 10 plus 10 to the power x. Very simple actually. We can see the differentiation of the denominator part is present in the numerator, means we can consider this denominator part, let x to the power 10 plus 10 to the power x is equal to t. Now differentiate both sides with respect to x, so it will become 10x to the power 9 plus 10 to the power x into log 10. This is the differentiation of the a to the power x formula we are applying here. A to the power x formula is a to the power x into log a. So here log base e, and this is into dt, this into dx, sorry, is equal to dt. So now our integrations will become I is equal to, here numerator is dt and the denominator we have considered t, so it is 1 by t, means log t plus c, and now we can replace the t values. So log of t is what? So t is x to the power 10 and 10 to the power x plus c. This is the answer. Now we'll move to the next question, that is question number we have 39. So the question number 39, we have given here integrate dx upon sine square x into cos square x. How we can do that? Here we have given only denominator part, numerator is basically 1. So how we can do this? We have to think here, because we cannot apply any substitutions directly here. We are going to rewrite this equation first. Here can we write it as just one second, here I equal to, we can say it is nothing but 1 upon sine square x into cos square x, and this dx will be as it is. And we know that 1 equal to, in terms of cos and sine, we have identity sine square x plus cos square x, means I am going to write the 1 in terms of sine and cos, so it will become sine square x plus cos square x, and this is divided by what? So it is divided by sine square x cos square x and dx as it is. Right now separately there are two terms in the denominator, so separately we are going to take the integrations for both, means it will become sine square x and this is divided by the sine square x cos square x, right, and this is into dx, plus second part is sine square, this time it is cos square, so cos square x divided by sine square x into cos square x into dx, right. Now we can see here this sine and sine is common, so it will get cancelled out. Here cos and cos is cancelled, so what are the remaining terms? Here we have remaining 1 by cos, so cos we can say it is secant square x, right, into dx, plus here integrations of, we have remaining only sine, so reciprocal of the sine is cosecant square x and into dx. So what is the integration of the secant square x? We know that it is tan x, right. What is the integration of the cosecant x? We know that it is minus cot x, so plus c. So this is the answer of the question number 39. If you see the options, it is present in the option number B, right. So this is the last questions of the exercise. So thank you.